Lesson 7.5 is finding a trig ratio given another trig ratio. So we started off our trigonometry unit by developing the 6 trig ratios, our 3 standard ones, our 3 reciprocal ones. After we've done that, we associated those first of all with right triangles, and now we're starting to move towards applying those trig ratios to the coordinate plane where we're rotating a point. And we're going to emphasize now this rotation with an angle measurement. The last couple lessons, we built our terminology with rotation of angles, and we're also going to use Pythagorean theorem to help us draw some sort of triangle in a coordinate grid using a given ratio to find a different one. The beauty of it is we don't have to find the angle. If we know the ratio, we can find the other ratios and then eventually find the angle and or ratio depending upon what we need to find. All right, so to do that, there's some steps. I have 4 examples here I'm going to show you. You kind of can decide. Each is slightly different. Decide if you want to fast forward or move forward and try on your own and then look. That's kind of up to you. So I'll show you how I do it. Each problem I do very, very similar, and I use a picture to kind of help walk my way through it. Given this trig ratio here, what we're going to ask that you do is that you know some information that that's a rotation of an angle. We don't know what kind of angle it is. We know that it's in quadrant 1. We want you to find the other trig ratio or another trig ratio, which is the cosine ratio, in simplest radical form with a rational denominator. Okay, so basically, first of all, let's just put some context into what we're trying to find. We have some sort of angle measure that's been rotated in quadrant 1. So that's our first step. I want us to draw a little bit of a picture of what this is. Okay, so we have your initial side, and in quadrant 1, we'll just put it right up here. We don't know exactly what angle A is. We do know this, that's the terminal side of some sort of angle. Call it angle A, and it's in quadrant 1. All right, we know a little bit about that it's obviously less than 90, bigger than 0, but we don't know what coterminal angle it is, but its reference angle is somewhere in here. What we're going to then have you do is, so we're not going to be looking at any rotations here for this particular problem. What I want you to do is I want you to think about that if tangent of this angle is 7/24, and we remember that tangent is TOA, which means the opposite over the adjacent. If this angle is here, we're going to build a reference triangle, okay? And if that's the case, this side right here is the opposite side, and this is the adjacent side, okay? And if they say that 7/24, then we know the opposite side is 7, so let's write this. And we know the adjacent side is 24. Okay, so that helps us quite a bit, because if this is a right triangle, then we can find the hypotenuse by using the Pythagorean theorem. They want us to find the cosine value. We know the cosine is ka, which is the adjacent side over the hypotenuse. And so we have the adjacent side as 24. We want to find that hypotenuse. Here's how you find the hypotenuse. It's a squared plus b squared, 24 squared plus 7 squared equals c squared. So we're going to simplify a little bit. This is 625. You can use your calculator for that. Square root of that is 25. That means this hypotenuse here is 25, which means now I can find this ratio. The ratio is the cosine of this angle, which is undefined. We don't know that yet, is equal to the adjacent over hypotenuse. So it's this ratio, 24/25. Just make sure it's in simplified form, no radical in the denominator, and that's it. Okay? So we'll slowly turn up the heat a little bit here. They can give us any one of our 6 ratios. And from that, we should be able to draw a picture and find any other ratio of that. And it all has to do with drawing a right triangle here. So it says it's in quadrant 1, so I'm going to cross these quadrants out. I'm going to draw this side. Let's do this. Let's use a different color. Sorry about that. So there's our terminal side, initial side. We're going to call it angle A again. And now what we're going to do is we're just going to draw a 90-degree reference triangle here. All right. And it's telling us that the ratio of secant is root 13 over 2. Well, secant is the reciprocal of cosine, which I use ca for cosine. And so secant, that's how I memorize it, is the reciprocal of that. So instead of adjacent over hypotenuse, secant is hypotenuse over adjacent. Okay? That's secant. So if they say the secant is root 13 over 2, then that means the hypotenuse is root 13. Let's draw it on our picture. And the adjacent side is 2. There's my adjacent side. And if they want me to find the value of cosecant, well, cosecant is the reciprocal of sine, and I use so for sine. So the reciprocal is ending up, cosecant is going to be the hypotenuse over the opposite side. If I look at my picture right here, I have the hypotenuse, but I don't have this opposite side. So I can use the Pythagorean theorem to find that. I can call that whatever I want. Let's call that A. So we know that A squared plus B squared equals C squared. That's the hypotenuse squared. So let's do a little arithmetic here. A squared, this is 4. This is 13. I'm going to subtract 4 from that. I get 9. A is 3. So I'm going to write that. That's what A is. And A, remember, is my adjacent. Let's just write that. That's my adjacent side. So we'll put that into our picture here. That side is 3. Now I can answer what cosecant is. Cosecant of angle A, that's what it's asking for, is equal to hypotenuse over the opposite. The hypotenuse is root 13. And my opposite side, I'm sorry, I don't know why I put adjacent here. My bad. This is the opposite side. Hypotenuse, just because there's an A maybe, I don't know, over the opposite side. I use my SOHCAHTOA to help me. I switch things around. I write it down, done deal. So, yeah, more of the same here. This works for any one of our trig ratios here. Again, this one says this in quadrant 1. Question 4 and 5, I switch up the quadrant. So you may want to try this one on your own. That's kind of up to you. Let's draw, here's your initial side. Here's your terminal side. We are going to then, from there, create this reference triangle. It's a 90-degree reference triangle. And it says that the cotangent of this angle, this is angle A right here, is 5 over 6. Here's what that tells us. Cotangent and tangent are reciprocals. And tangent is the opposite over adjacent, so that means cotangent is adjacent over the opposite. That's what cotangent is. So if they say cotangent is 5 over 6, then I know the adjacent side is 5 and the opposite side is 6, just like this. That allows me to find this value here, and I'm going to need that value a little bit because it says find the value of cosine A, and cosine A is ca is adjacent over hypotenuse, and so I need to find this hypotenuse value here. I'm going to use Pythagorean theorem. 5 squared plus 6 squared equals, let's call this C squared for now. Call this value C. It's the hypotenuse. So let's simplify a little bit. This is going to be 61. This is the square root of 61. So that just means that this side is irrational, and that is in simplified radical form. And then my cosine is the adjacent over hypotenuse. So here's what I do. Cosine angle A equals the adjacent side over the hypotenuse. This is why this is a spicy problem, because I'm not done here. You know better than this. You can't leave that rational, you have to rationalize the denominator. And right now, this is an irrational number. So once we get to this point, here's how we rationalize the denominator. We multiply the denominator by the square root 61 and multiply the numerator by square root 61. what happens is it ends up being 5 root 61 all over root 61 times root 61 is 61. And then just double check, is 5 and 61, are there any factors here that can be canceled? If not, final. This is where I would suggest try these on your own. And I'm just going to do them out here. You can either speed me up or stop and then just fast forward to the end. But I'll talk through it for those that still want to stay with me or for those that just want to see the answer at the end. Okay, so fine, given that tangent of theta is 40 over 9 and it terminates in quadrant 3. So this is important to have this picture to help us identify this. Quadrant 1, quadrant 2, here's quadrant 3. So here's what it's saying. It's saying we have, let's draw this. We have this initial side and we have this angle that terminates in here. We don't know what this angle is. We know it terminates here. So our first job here is to draw a 90-degree reference triangle here. And then what we're going to do is we're going to start labeling some of these signs. Tangent, I use the shortcut TOA, which means opposite over adjacent. And so that means my opposite side is 40, my adjacent side is 9. But I have a little bit of an issue here because this is in quadrant 3. And I'm showing direction. I'm to the left of the origin. I know that this must be minus 9. This is the adjacent side. And then this must be minus 40. This is the opposite side. Now, the reason why I know those are negative is because of where it's located. It's located in the third quadrant. And so any points in here have coordinates where the x value is negative, the y value is negative. And this also is true. Because if you have a negative divided by a negative, that does end up equaling 40 over 9. And so use the picture to help us here. The hypotenuse, by the way, hypotenuse is always positive. You don't have to worry about this hypotenuse being positive or negative. In this case, just be careful here. We need to find sine, which is opposite over hypotenuse. So I need to definitely find this hypotenuse here. Let's call it C. Let's make sure you're careful though. We're going to square negative 9. We're going to add that to negative 40 squared. And then we're going to take the square root of that. If you have trouble with these, if you don't use parentheses on your calculator and you're trying to compute it on your calculator, you're going to run into some issues here. So you just need to know that anytime you square a positive or a negative number, that is positive. So you should get 1681 here. Double check your math if you don't. And the square root of that is 41. That makes this measurement right here 41 degrees. Sorry, 41 units, which allows us to find out what the value of sine is. So the sine of this angle is opposite over hypotenuse. This is my opposite side, and this is my hypotenuse side. So it's negative 40 over 41. If I simplify that, I'm just going to put the negative sign right out in front. And that's what the sine of angle theta is. Okay, one more here. This angle terminates in quadrant 3. We'll do another one of these quadrant 3 terminators. This is quadrant 3 down here. Let's draw our angle out. Initial side, terminating side. Let's draw our reference triangle out right here. Right angle. Notice how I'm always going back to the x-axis. The idea with the reference is important. And then let's label some sides. So here it says that the cosine is negative 20 over 29. So cosine uses ca. That's adjacent over hypotenuse. Negative 20 over 29. Now with the negative sign here, I'm not totally sure what's negative, other than I know the hypotenuse is always positive. That means this adjacent side must be negative. The picture also helps me here. This is my adjacent side here. So it makes sense that to the left that's negative. My hypotenuse is positive. Here I need to find my opposite side because it wants to know tangent, which uses TOA, opposite over adjacent. So to do that, I'm going to use Pythagorean theorem again here, but I'm going to use it slightly different. So this opposite side, let's call that A. It's either A or B. It doesn't really matter. So A squared plus B squared equals C squared. So we're going to do a little arithmetic here. Use your calculator. We're going to get A squared equals, we're going to take this away from this side. So we'll fast forward a little bit here. So we get A equals 21. All right, that's this value. Now, if you look at this picture here, this is where I think the picture is super important. Got the wrong utensil here. Sorry about that, you guys. I need the eraser. I think it's super important to look at my picture here because this is a value of negative 21 units. It goes down. So any point in this quadrant, this picture helps me identify that, this is a triangle. Not saying that that's a negative value of a length. It's just a reference triangle. So we're really looking at the rotation of this angle and this point here. So, all right. So TOA, opposite over adjacent, is ultimately what we're going to find here. So tangent of theta, the opposite side, if I use my picture, negative 21 over my adjacent side, negative 20, negative by a negative, simplify that, 21 over 20, no common multiple, final, heart it, because I love this one. And that's it. Good luck, you guys. I think that's, we'll move on to some more ratios now, rotating points next. Good luck.